Dear friends, I am Umesh Shelke, Assistant Professor in Chemistry, Department of Chemistry, Rayat Section Samstha's Art Science and Commerce College, Ramannagar, Burli, Taluka Porus, District Sang. As we have studied in the previous lecture about the properties of the benzene molecules. So in this lecture, we will discuss reactions of aromatic compounds. So aromatic compounds are the different class of compound, and it specially shows the specific reactions. So aromatic compounds, unlike aliphatic compounds, do not undergo substitution. Instead, it shows the electrophilic substitution reaction when treated with the suitable electrophile. As we know, the pi electron cloud is present above and below the benzene ring. That means it is susceptible for the electrophilic substitution reactions. As it is clear from the structure of benzene that the double bond which is present in the benzene molecule is not a static. That's why it is unable to show the addition types of reaction as the unsaturated compound shows. Next is a aromatic compound shows two types of substitution reactions. So where the substitution reactions are of two types: electrophilic aromatic substitution reactions, abbreviated as SEAR. Second one is nucleophilic aromatic substitution reactions, abbreviated as SNAR. S for substitution, N for nucleophily, and AR for aromatic compounds. Electrophilic substitution reactions. So here, electrophilic substitution reactions. Due to the presence of 6 pi electron in the benzene ring, it acts as a nucleophile and here react with the electrophile. The reaction involving substitution, that means replacement of hydrogen atom from the benzene by an electrophile as E+, called as electrophilic substitution reactions. So general reaction is when benzene is treated with the suitable electrophile as a E+, so it undergo electrophilic substitution reactions where this hydrogen get replaced by the E+, and it gives replacement product, the incoming electrophile get attached. So overall this reaction is called as electrophilic substitution reactions. But this reaction is not so simple. It has some steps. So the step of the reactions or path of the reaction is called as the mechanism of the reaction. So in this lecture, we will see the general mechanism of electrophilic substitution reactions. Involve the following steps. Step first, generation of an electrophile. So generation of electrophile is an rate determining steps in this respect. So when the reagent undergo heterolytic bond cleavage process, it results into the formation of plus charge species and negative charge species. So generation of electrophile takes place as a E+ and Nu- acts as a base and represented as B. In step second, formation of sigma complex. So here, once the benzene ring has a pi electron cloud, so these undergo the attack of electrophile over the nucleophilic aromatic rings. So it results into the formation of attack of the electrophile is a slow step and rate determining step. It undergo delocalization of the plus charge which is created on the molecule, and it results into the formation of sigma complex that is called as carbocation. So here, these are the resonating structure by produced by attacking of electrophile on the benzene ring. So this positive charge is created on this benzene ring. This bond gets shifted over here, and the formation of plus charge here. So the second resonating structure, this is the third resonating structure. So we can say the positive charge is delocalized all over the 5 carbon atoms, and it is represented as a circle and plus, so resonance hybrid. So this intermediate is called as valent intermediates. So these are the canonical forms. Through this, the molecule gets stable, and in final steps, that is third step, removal of proton from the sigma complex molecule to form the substituted products. The base which is generated in the first step, that is generation of electrophile, abstract the proton from the sigma complex molecule, and it results into the formation of substituted products. So this is the mechanism of electrophilic substitution reactions. So types of electrophilic aromatic substitution reactions. So there are so many types of electrophilic aromatic substitution reaction, but we have to study here nitration. In nitration, it uses NO2 plus as an electrophile, whereas in second is the sulfonation, it uses SO3H plus as an electrophile. In halogenation, it uses the X plus, that is halogen, it may be chlorine or bromine as an electrophile for the substitution reactions. Then fourth class of electrophilic aromatic substitution reactions is Prederkraft alkylation and acylation. It uses R plus as an alkyl electrophile or acyl as an electrophile in Prederkraft acylation reactions. Simply we can say the nitration is the replacement of hydrogen from the aromatic system by the NO2 groups is called as nitration reactions. Similarly, the sulfonation and halogenation and Prederkraft alkylation and acylations as well. So in this lecture, first of all, we will discuss the nitration reactions. The substitution of hydrogen by the nitro group is called as the nitrations. So this nitration reaction is proceed through the aromatic electrophilic substitution reaction. When benzene is treated with the nitrating mixture, that is the mixture of nitric acid and sulfuric acid, it results into the formation or generation of nitronium ion as electrophiles, and it results into the formation of the product that is called as nitrobenzene. Where in overall reactions, the hydrogen atom from the benzene get replaced by the NO2 groups. So we will see how this reaction is proceeded by its mechanism. We know that the mechanism is nothing but the path followed by the reactant molecule to convert into the product is called as the mechanism of that reactions. So mechanism of nitration involves the following 3 steps as we are studied in the previous general mechanism. First step, generation of nitronium ion. So here nitric acid and sulfuric acid get react with each other. It results into the formation of nitronium ion. So in these two acid, nitric acid and sulfuric acids, so nitric acid acts as a base, whereas sulfuric acid acts as an acid. It donates proton to the nitric acid and it results in the formation of nitronium ion. So it is an active electrophile in electrophilic substitution reaction. After the generation of an electrophiles, so this nitronium attack on the pi electron cloud of the benzene molecule and it results in the formation of sigma complex carbocation. So this carbocation which is formed by the attack of the nitronium ion, so it is unstable and it undergoes delocalization of pi electron and it results in the formation of resonance structure of that sigma complex. So here first structure, as the positive charge is present on the carbon number 1, so get shifted over here, it results in the formation of second resonating structure. Similarly, the third resonating structures. So these are the resonance structure or canonical forms of the sigma complex produced during the attack of the nitronium ion as an electrophiles. So we can see the resonance hybrid, the positive charge is created on the benzene by the attack of nitronium ion. So it results into the formation of 3 canonical structure. It means this positive charge is delocalized over the 5 carbon atoms and it is denoted as resonance hybrid structures. So called as valent intermediates. Next, third step, that is removal of proton from the sigma complex. So it is a first step. So here the base, that is SO3H minus, is generated in the first step. Abstract the proton from the carbon atom which contains the electrophiles, and it results into the formation of the nitrobenzene as a product. So this is all about the nitration reaction.